My name is Fikri Suhairi, and I am final year student in Bachelor of Surveying Science and Geometry program at University Technology Marapelis. Today, I am proud to present my research entitled Multi-Factor Assessment of Mangrove Stress in Sungai Pulai JOHOR using the Google Engine platform. This project explores the complex environmental pressure facing our coastal ecosystem using advanced cloud computing and spatial statistics. Mangrove forests are more than just trees. They are the vital blue carbon store and the first line of the defense against coastal erosion and storm surge. However, these ecosystems are under constant threat from both climate change and human erosion. While most traditional studies rely on a single vegetation index to monitor health, my research adopts a multi-factor approach by integrating health, temperature, moisture, and salinity indicators, so we can detect the subtle early stage of physiological stress that single-factor method often overlook. This study is driven by three core objectives. Firstly, to derive specialist spectral indexes, specifically Enhanced Vegetation Index (EVI), Moisture Stress Index (MSI), Normalized Difference Salinity Index (NDSI), and Land Surface Temperature (LST), as provide for environmental stress. Secondly, to classify the stressors into objective health categories. And thirdly, to analyze how these drivers vary across space using geographically wedged regression (GWR). Our study area is Sungai Pulai Mangrove Forest Reserve, covering over 9,126 hectares. It is Malaysia's premier riverine mangrove complex and was declared as a Ramsar site in 2003. This area is a critical monitoring site due to the intense coastal squeeze caused by nearby port construction, aquaculture, and rapid urbanization. To handle such a large dataset, I utilized Google Engine to process land satellite imagery. To ensure accuracy, I applied a 6-month maiden composite from January to June for both 2050 and 2025 to capturing the peak stress period in Malaysia. I create a multi-band feature stack, allowing us to analyze vegetation vigor alongside thermal and hydrological factors simultaneous. For the classification, I deploy the random forest algorithm configured with 100 decision tree. This machine learning approach uses majority voting across the assembler to provide stable, highly accurate result. To make sure the model robust, and I train it using 300 expert verified reference point, which is 100 for each class. First class is stress vegetation, second class is moderate vegetation, and lastly healthy vegetation. Moving to the result, our classification model performed exceptionally well, is an overall accuracy of 91.56% for 2015 and 91.50% for 2025. The map revealed a startling trend: stress vegetation nearly double over the decade, rising from 2.85% to 15.66%. Especially, this regression is not uniform. We see the most significant decline along the southern coastline and riverbank. The transition matrix shows that we lost over 550 hectares of moderate vegetation as it shifts into the stress category, indicating that environmental pressure is overwhelming the forest's natural resilience in this boundary zone. But the real question is, what is causing this stress? To find out, I applied geographical wedge regression. Unlike the standard global model that assumes stressors at the same everywhere, our most critical finding is the temporal shift in stress driver. In 2015, moisture stress was the dominant constraint with a mean negative coefficient of negative 0.802, meaning water deficiency was the primary limit on canopy vigor. However, by 2025, soil salinity emerged as the most severe threat. Its average negative impact was to negative 0.218, but more importantly, localized impact reached extreme levels of negative 2.858. This proves that rising salinity, likely driven by sea level change and tidal inundation, is now the primary force accelerating degradation in Sungai Pulai. In conclusion, this research provides a high-resolution route map for conservation. I recommend that management effort prioritize target the restoration in the southern salinity hotspot identified here. By using multi-factor framework in Google Earth Engine, we can now monitor this Ramsar site in near real time to protect its feature. Thank you for your attention.